Hi, this is Dr. Foley. This video is part of the Chemistry 151-4 guided learning activity. In this video, we're talking about naming ionic compounds. The first thing you need to do when naming a compound is to identify it as ionic, covalent, or acidic. Ionic compounds are always made from a metal plus a nonmetal. And how do you know if something is a metal? Well, you're going to look at the periodic table. So on this periodic table, you can see that half of the elements, or over half the elements, are coded in red. The other half are coded in yellow, and there's this jagged line in between. The jagged line separates the metals from the nonmetals. The jagged line should always be on a periodic table somewhere in the classroom. So you should always be able to look at your periodic table and tell if you have a metal plus a nonmetal. Okay? After you've determined that you have an ionic compound, you need to name the ions. Naming ionic compounds is pretty simple. All you do is name the first ion and then name the second ion. So let's take a couple of minutes to talk about how to name ions. For the metal ions, or the positively charged ions, they fall into two different categories. The first category are ions that are in group 1, 2, and 3 in the periodic table. Group 1 is here. Group 2 is here, and group 3 skips over the transition metals. If you remember learning about the different parts of the periodic table, this part, the lower part, is called the transition metals, and transition metals are hard to predict their properties. So one of those properties is the charge that they form in their ions. Okay. For group 1, group 2, and group 3, we know that they always form +1, +2, or +3 charges, or almost always. Okay. So for these ions, we simply name them the same as their metal. So for example, calcium ion, the ion of calcium metal, has a +2 charge because calcium is in group 2, and we call that the calcium ion. For the transition metals and a few metals towards the bottom of the periodic table, they can form ions of variable charge, meaning that the metal can form multiple ions. An example of this is copper. Copper can form a +1 ion. Copper can also form a +2 ion. If I want to name a compound containing this ion as opposed to that ion, I need to tell you that it has a +1 charge, not a +2 charge. And how we do that, how we communicate the charge state of the ion, is by writing the charge in parentheses, following the name. So this would be called the copper 1 ion, and that would be called the copper 2 ion. Note that this refers to the charge, not to the number of atoms in the compound. Okay? On the other side of your compound, you're going to have a nonmetal ion. Nonmetal ions also fall into two categories. The first category are ions that come directly off the periodic table. They come from group 5, 6, and 7 because these are the nonmetal portions of the periodic table. So in our periodic table, this is group 5, this is group 6, this is group 7. Group 8 doesn't form an ion because it already has a full octet. In order to achieve a full octet, group 7 elements will gain 1 electron, so have a -1 charge. Group 6 will have a -2 charge, and group 5 will have a -3 charge. Okay. If they come directly off the periodic table, what we do for the nonmetals is we drop the ending and we add IDE to indicate that it's now the ionic form. So for example, chlorine becomes chloride, which is a Cl- ion. Oxygen will become oxide, and that will be the O2- ion. The other group that they fall into are polyatomic ions. Polyatomic ions are covered in a different video, but you essentially need to memorize the different polyatomic ions. You need to be familiar with what they look like, with what their charge is, and with their names. Okay. Now we're on to moving to naming ionic compounds. Again, naming ionic compounds is relatively simple as long as you know how to name the ions. You simply write the name of the metal ion in front of the name of the nonmetal ion. So, for example, this ion is called the barium ion. This ion, the Cl, is called the chloride ion. So the compound is called barium chloride. Below it, I can see that this is the copper ion. I know that copper is a transition metal, so I'm going to leave some parentheses here because I know that I need to specify the charge of it. This ion is called the nitrate ion. Okay. I also know from memorizing my polyatomic ions that the nitrate ion has a -1 charge. Remember, for something to be considered a compound, the charges on the positive ions and negative ions have to neutralize. Because I have a -1 charge on nitrate and I have 2 nitrates, my overall negative charge is -2. That means my overall positive charge must be +2. Because I have only one copper ion, the charge on that copper ion then must be +2. So this is copper 2 nitrate. You also need to be able to use nomenclature to go the other way. So to start with the name of the compound and figure out what the formula is. So to do this, you simply have to decide what each name in the compound represents. So for example, iron is represented by the abbreviation Fe. This 3 tells me it should have a +3 charge. Oxygen is represented by the abbreviation O. I know oxygen is in group 6, so it must have a -2 charge. Again, because the charges need to neutralize, I take this 2 and write it as a subscript for my iron. I take the 3, write it as a subscript for my oxygen, and I arrive at the formula Fe2O3, and that is the formula for iron 3 oxide. Okay. The next example is sodium sulfate. So I recognize that sodium has the abbreviation Na. Sodium is in group 1, so it must have a charge of +1. Sulfate should be a polyatomic ion that you recognize. The sulfate ion is SO4 2-. In this case, I'm going to write the sodium. I add the 2 from the superscript of sulfate, and I write the sulfate. Sodium has a superscript of 1, a charge of 1, so I don't need any subscript here. That's all for this video. See you next time.